Hello friends, this is Abhishek Chaurasia from Geological Survey of India, working under Ministry of Mines, India. Today we are going to talk or discuss about the very highly sophisticated instrument, that is high precision GPS global positioning system. This is a very used to GPS to the global level and as well as national level. This is an instrument which are very commonly used for the basic coordinate positioning of any object on the global level or national level. What is this HPGPS? HPGPS is stand for High Precision Global Positioning System. That position can be achieved by combining global navigation satellite system, which is totally based on GNSS. These satellites such as GPS, GLONASS, Galileo, Baidu, these all are satellites are launched by the different country for the different with the different resolution and their accuracy. These GPS and satellite systems are basically work on the real-time kinematics, that is a RTK technology. These whole satellites are monitored and operated by the course or permanent reference station, that is continuously operating GPS reference station. These stations are basically work for the basic coordinate and the real time position of the any object on the global level. This core system or permanent reference station comprises a GPS receiver with antenna and with the battery system, which are permanently stable and installed on a particular location for a longer period of time, of the better resolution and the accurate position of any object up to the millimeter level. Why we need this HPGPS? Earlier we have a global positioning system over here, but this HP high precision GPS are needed due to the development of the industrial revolution and the security problem over the global level. The high precision GPS is much more required for the better accuracy and better resolution of any object on the globe. For determining other than the positioning of the object, this HPGPS used for the determination of the crustal movement and motion over the period of time. For differential GPS, that is DGPS, services over many hundreds of kilometers to determine coordinates to accuracy of the order of a few centimeters for vegetation, topographic mapping, forestry, precision agriculture and other uses. For weather monitoring and forecasting of the weather prediction, the several antenna are put over in the HPGPS for better forecasting of the weather. Here we have a international and national status for the HPGPS. In the international status, USA is the leading position in the HPGPS with 3,570 number of permanent stations continuously working and acquiring the data with the help of different satellites of the different country. In the list, we have a second, the Canada with the 3,078 number of permanent station. The third one is the Sumatra with 49, the Switzerland with the 30 at the fourth number. In the national status, the total permanent stations are 18 installed by the various agencies like NGRI, NQuas, GSI and other. But here as we work in the FSP mode, that is Field Season Program mode in Geological Survey of India, we have planned for the 35 total permanent global positioning system over there. Up to this 18-19 program, we have already installed the 18 number of permanent GPS station with the various locations like Gandhinagar, Patna, Chandigarh, Chennai, Visakhapatnam and the other locations. But up to the end of the 2020, we have targeted to install up to the 35 number of total permanent GPS station over the national level by the Geological Survey of India. Now come to the structural point of this HPGPS. With the structural point of view, we could divide this HPGPS into the three segments, that is the space segment, control segment and the user segment. The space segment, the first one, This space segment uses the different satellites over the view of the globe. This GPS uses a constellation of 24 to 32 satellites equally distributed in 6 orbits that orbit the Earth at about 11,000 nautical miles once every 12 hours. The orbital position is constantly monitored and updated by the ground stations, that is the permanent GPS stations. The signal travel with the speed of light from the satellites. This constellation design at least 4 satellites should be in view for the better accuracy and the accurate positioning of the object over the globe. The second segment is the control segment. This control segment is constituted with the 4 substations, that is master control station, the ground control station and the ground antenna. This master control station is located in the Colorado, which are the which play a leading role controlling of the various signals of the various satellites. For the better accuracy of the positioning, there is a hard fact rule should be there that the 4 satellites should be in view for the receiver to receive the signals from the following 4 satellites. The third one is the user segment. This is also called the end segment also. This user segment is composed of hundreds of thousands of US and allied military users of the secure GPS precision positioning service and tens of millions of civil, commercial and scientific users of the standard positioning services. The position and coordinates are used by the various type of user over like security, for medical uses, for agriculture uses, for weather forecasting, and the distance and direction of the movement of the 2 waypoints could also be monitored or calculated by this HP global positioning system. Travel progress report could also be measured, or their accurate position and the direction could also be calculated with the help of HP GPS. These are the models which are available. Basically, the HP GPS, that is a high precision global positioning system, is available in the 2 models which are manufactured basically by the Leica, which are headquartered in the Switzerland. These 2 models are GR25 and GR50 with the antenna connection, which have a different signals and rays which produce with different wavelength of different wavelength signals, that is AR10, AR20 and AR25. Now come to the parts of the instrument of the HP GPS. Basically, it comprises a GPS receiver and antenna setup in a stable manner at a safer location with a reliable power supply. The power supply for this instrument should be 24/7 on the basis of regular basis. For the better and safe location, the open sky area should be preferred, or the high altitude area or highly elevated area should be preferred for the better signal received by the receiver with the different satellite system. The receiver operates continuously, logging raw data, outputting RTK, that is real-time kinematics and DGPS data for transmission to RTK, GIS and GPS navigation devices. Here we have a different slots over the receiver, like for the different function, like we have in SD card slot over there, we have a antenna, GNSS antenna over there, antenna cable port is there, USB cable port is there, power supply port is there, and in this here we have the basic GNSS antenna, which ultimately receives the signal from the satellites and it transmit to the receiver for the and save it there to transformation and analysis for the further analysis of the data. Now come to the working position of this setup or high global positioning system. This instrument basically works on the signal basis. These signals are driven by an atomic clock received by the various satellites, namely the GPS, GLONASS, Galileo, BDS, Beidou, QZSS and SBAS. and other satellites are also available. With these are the basic prominent satellites which strongly give the signals to the receiver. The fundamental frequency what we are using here is the 10.23 MHz, which works as a fundamental frequency for the receiver and the controller segment. Each satellite has a very accurate clock, which is an atomic clock with a high accuracy, that is with the 0.00000003 second. Up to this level, we can measure the crustal movement, any minor movement or variation over the global level. We can also judge this place or movement over the global level. The receiver operates continuously, logging raw data, perhaps also streaming continuously of outputting raw data, and often outputting real-time kinematics and DGPS data for transmission to RTK, GIS and GPS navigation devices. Here we have a two carrier signals, that is a sine waves. Here we have a L1 with frequency 1575.43 MHz, the L2 frequency with the 1227.60 MHz, and L5 with 10.23 MHz, which is works as a fundamental frequency for the receiver. It continuously broadcasts signals and also send out to a stamp every time to the receiver and connect to the satellite with the receiver for the better for the data recovery and save to the data directly to the receiver of the instrument. After receiving the data with the help of in the form of signal with the satellites and receivers to where we have saved these data, the various errors could be there for measurement or in the process of saving the various data. That could be the satellite orbit errors. These satellite orbit error could be minimized by the IGS orbit need to be used during data processing for the better accuracy of the and minimize the satellite orbit error. The satellite clock error could be there, might be there any battery problem. That's why the satellite clock could full of error, and the data which we have saved in the device that is the receiver could be full of error. The tropospheric refraction, that is due to the different layer of the atmosphere of the earth, the various topographic refraction, that is refraction, and due to reflection the various signals could be deformed or refracted from the different layers of the atomic for the atmosphere of the earth. The next one is the ionospheric refraction. In this ionospheric refraction, the various ionic exchange processes could be there for the diffemination and the reduce of the error signals frequency and their power of the signals. The antenna phase center problem could be there. The last and the most important error is the multipath error. This is the error which are commonly observed or measured by the receiver of the HP GPS. This multipath error could be there due to any obstruction over nearby the antenna or the receiver, which works continuously by in the 24/7 mode. In this process, we could have a vegetation problem or the high rise building over there. The high hill problem could be there. Any obstruction which obstacle the signal directly, which could not directly received by the receiver from the satellites. Now come to the why we need this HP GPS. Whether we have a lot of instrument for the positioning of the or any object in a global level, but other than the positioning, we have additional benefits of the HP GPS. That one of the basic additional feature of this HP GPS is the crustal movement measurement. This is the very crucial application of this HP GPS, and a variety of other spatial scales and the topographic mapping, forestry and precision agriculture other could be measured, or these are the additional benefits for the HP GPS for weather monitoring and prediction and the forecasting, of the weather, this instrument could also be utilized. The next and the foremost important application is this instrument, that is a high precision global positioning system, is geodynamic study to find out high strain zone. These are the very burning topic of on the global level, because the most of the country on the plates, the continental plates and the ocean plates are facing the earthquake problem, which are very crucial for the mankind and the societal issue. With the help of this HPGPS, we could easily measure the strain zonation, between the two plates, that is whether it could be continent or ocean or continent or ocean. Here we have a map of the Indian plate and the Eurasian plate and the collision zone between these Indian and Eurasian plate, which form the high altitude and the high elevated the Himalayan range, which stretch about 2300 km from the Kashmir to the Arunachal Pradesh. This zone shows the high strain zonation by the collision of these two plates, and due to this collision, the high strain zone are created over there. The other uses of the high precision global positioning system is a GIS platform. GIS platform is the mapping program which is diverse domain, which have a diverse domain, namely mineral exploration, NGPM, NGCM, engineering geology, landside studies, and the other uses, which needs to be projected on GIS platform for the better understanding and the better exploration techniques and process and the way to explore the better and accurate location of the point for the mining section. Other than this mineral exploration, NGPM, NGCM, and this applied section, we have a coordinate mark and the positioning of the any object on the global level. Now come to the second portion of the talk is the high precision global positioning system. That is the data analysis. The receiver which collect the data in the forms of signal, that is in the form of digital signal in the form of 0 and 1 to form, and these data is analyzed by these data are analyzed and for the various application of the societal impact. In this queue, we have various software which do the data analysis portion of this HPGPS. In this section, we have basically the three software which directly analyze the data of the receiver, which are directly stored by the receiver in the form of signals of the various waves. The first software is the Bernice. This software is developed by the University of Bern. The second one is the Gypsy or OSIS, that is developed by the NASA and mainly utilized by the NASA. The third one is the GAMIT and GLOBK, which are mainly used by the Geological Survey of India. In this segment, we are going to talk about the GAMIT or GLOBK software, which are very frequently used in the Geological Survey of India for the better data analysis and their application and the various application of these software, that is GAMIT and GLOBK. First, what we have received the data and the store in the receiver of HPGPS, that is in the form of MDB format. This MDB format of the data is first converted into the instrument independent format, that is RINEX. That conversion is done by the TechC software. Now we are going to discuss about the first one is the GAMIT software and what are the basic framework of this software for the analysis and their output of the final application. This GAMIT software is a series of programs that analyze GPS phase data to estimate parameters like station positions, that is coordinates, satellite orbital parameters, earth orientation, atmospheric delay, carrier phase ambiguities. These all could be measured by the GAMIT software. In the GAMIT software, basically we required various type of data like the L1 and L2 phase. These data are used for the parameter estimation, The P1 and P2 range measurement used to help clean phase data. This used to estimate receiver clock offset with tolerance of up to the 1 microsecond. The LC phase, proportional to geomorphic sensitive insensitive linear combination of L1 and L2 phase of data. In continuation of the data type, we have a LG phase which measures ionospheric delay only. Insensitive, which is directly insensitive to geometry. Wide length, that is WN, linear, that is a linear combination of L1 L2 and P1 P2 of phase of data. Here we have required the various file for the processing of the data with the help of GAMIT software. In this sequence, we required a broadcast ephemeris from receiver, SP3 orbit files from IGS, GAMIT G file should be required for the data analysis with the help of GAMIT software. And the satellite clock file, that is J file, the ocean tide file should be there for the data analysis with the help of GAMIT software. The moon and sun ephemerids, orbit integration, solid earth tides, leap second file, that is UTC versus GPST files should be there for an analysis of the data. Satellite information file should be there, information about station like their position, position of the receiver and antenna, the antenna height. These all information should be required for the data analysis with the GAMIT software. After the data processing in the GAMIT software ultimately results into a loosely constrained solution with about 10 meter of accuracy. In this process, we estimate for each site, including IGS sites, that is station coordinates, satellite orbital parameters, zenith tropospheric, satellite and receiver, and the phase ambiguities. This ultimate processing of the data with the various data and the file, the GAMIT software gives the H file in ASC second mode, which is used directly to the GLOBK processing of the data for the final analysis. Now come to the second one of the software analysis, that is a GLOBK. GLOBK combined solution is a combined solution from GPS, SLR and VLB1 data via their parameter estimates and full covariance matrices to estimate other parameters like site velocity, which is temporal derivatives of the position in up to the millimeter level per year. Require a time series of measurement, satellite orbit adjustment, EOP parameters and other parameters like co-seismic displacement should be there for the better analysis through the help of GLOBK software. In GLOBK software, we required the binary H file generated by the STOGLB from GAMIT H files, that is ASC second. The command file should be there for the analysis of the with the help of GLOBK software. Operational file, that is orbit file, EOP in the form of PMU file, earthquake representative file, coordinate and motion file should be there. The common application of the GLOBK is to analyze the repeatability analysis, that is individual season, combined files should be there. Combined season to get average position over the experiment. Combined average position of in satellites, various velocities and or earth offset and post seismic motion could also be measured or analyzed by with the help of GLOBK software. This is the ultimate graph drawn with the help of GLOBK after the processing of the various data and their processing with the help of GAMIT and GLOBK software. We get a distance versus the time velocity graph. In this graph, we could easily see in the vertical section we have a displacement and the horizontal section we have a time graph. In the normal condition, there is a very minor oscillation in the form of wave, but in the case of earthquake duration, we have a very high with a very high amplitude of frequency and the very high amplitude with of these waves. Here we could see the frequency and the very high amplitude of the waves. This is the graphical presentation of the final output. this is performed by using GMT software. After processing of the various data which are received by the receiver of the HPGPS, these HPGPS and processing of these data by the help of GAMIT and GLOBK software, and including with this software, with the GMT software, we ultimate have displacement and the displacement with the time and the direction of the movement of the crustal plate throughout the time scale.